welcome to the workshop on Basic Mac. Today I would like to cover sort of what Basic Mac is, what the architecture is, and how you can download it, build it, put it onto a device. Just sort of go a little bit beyond what we have in the README or in the Getting Started guide. So Semtech released recently a new program called LoRa Basics, where we're trying to put basic building blocks that can be used to build LoRa applications into the wild, so to speak, as an open source project. And today we're going to have workshops on two of those components. One is Basic Station, which is sort of the next generation packet forwarder to be running on gateways. And the other one is Basic Mac, which this workshop will be about, which is the end device stack, basically, which can be used to write device firmware. And all these things are available on GitHub, of course, where you can download them and give them a try. Basic Mac is a device stack that implements the current LoRaWAN specification 103, support for classes A, B, and C. It's multi-region capable, meaning it can support different regions either concurrently or selectable at compile time. So at compile time you can say I want to have a firmware that supports EU only, or US only, or AS923 only, or you can have a firmware that can support EU 868 and US 915, and that at runtime you select which region that you're currently working on. It will send a join request on the join frequencies for that particular region. It is written in C and it's designed to be portable. It depends on a very lean runtime, which there's a portable implementation for, but you can also supply your own runtime as long as it implements the API that is expected. It has radio drivers for the 127276 and the 6162 drive radius at the moment. I say at the moment because this is one of the areas that, of course, we're working on getting all the Semtech radius that current and future supported. And then one important aspect of it is the simulation. So there's a complete simulation environment for it that you can use for writing tests and so on. And then also it's already deployed on hundreds of thousands of devices in one form or another out there. So it's a stack that's actually being used out there in active customer deployments. I want to go a little bit about the history. So this is not a brand new stack. This builds on top of the original IBM Elmic stack. So in the very, very beginning, when LoRaWAN was still called LoRaMac, at IBM we did an implementation of that protocol. And at the time it was intended sort of as a test. We were running specification at the same time we were implementing both device side and server side. The idea was to get something to work there, validate immediately the specification. So that's when it started in early 2004. Then about 2 years later, that development effort at IBM stopped. It was at that time it was open source, and we then forked it out in TrackNet and used that as the basis of our stack at TrackNet. And then for the next 2 years, it developed sort of in a different way because now we were focusing on producing actual products. And so what happened during that? So when we at IBM, it was the runtime, for example, was running on a STM32 L1, which is Cortex M3, and then at that point when we switched to TrackNet, these requirements changed. We did a port of the runtime to Cortex M0 Plus. A lot of effort, which during the IBM times was not viewed as essential, was put into making sure that we can do things like being conservative on power consumption. So there were improvements done in the runtime and in the HAL as well to support these kind of things. So a lot of things happened during those years, and then when Semtech acquired TrackNet, now this became, or TrackNet, the TrackMac that we have back then became the basis of the LoRa Basics Mac that we have today. So this stack has evolved over a number of years, and in certain areas that certainly shows if you look at the code. And we intend to continue this development down the road. As you may know, Basic Mac was selected by the technical committee as one of the reference implementations, which is not an endorsement, but more a commitment from our side that we will implement the specifications as they are being developed in the TC, because in the TC we have a new rule that says we will not release a specification until there is a reference implementation that implements the specification, and there is a certification specification for it, and a reference implementation passes that certification specification. So the selected reference implementations, ARM embed is another reference implementation. Basically, that's a commitment of us saying we're going to work with the TC to make sure this stuff is implemented, passes certification.